Hello everyone and welcome back to Arctic Retro. In this video I'm gonna revisit my old Macintosh Classic computer, which is running here on my bench already. It has a couple of issues that I'm gonna take a look at, and also I'm gonna build an expansion for it, namely the BlueSCSI version 2. I think it's been a couple of years since I started this machine last time, and it still works. So the issue I'm gonna take a look at and try to fix today is that it doesn't have any sound. So let's open the control panel here and go to sounds, and the volume is max, but no sound. And it didn't have sound the last time I tried this machine either. Besides that, it is actually working fine. It already has a hard drive in it, as you can see, Mac HD here, and that is in fact a BlueSCSI, but it's an older version that I installed a couple of years ago. Unfortunately, this machine right now runs the Norwegian version of the operating system, so that the text and stuff is in Norwegian, and it's currently running System 7. It has 2 megabytes of RAM total. The system has 1 megabyte. The floppy disk drive is also supposed to be working. Let's check it out if it still is. Yeah, it shows System 7 disk. But it's empty. Yeah, I just loaded a photo of Steve Jobs. Unfortunately, no colors on this machine. This video is sponsored by PCBWay. In my videos, I often have the need for some PCBs for my projects, and my favorite PCB manufacturer is, of course, PCBWay. If you need to have produced your own PCBs, then just head over to PCBWay, where you can upload your Gerber files directly, or you can choose from a wide variety of ready-made PCB designs. And check out PCBWay 8 project design contest that has started now, where you can compete with electronics, mechanical and AIoT projects. If you have good ideas there, you can now participate and win great prizes. So go ahead and visit PCBWay.com and check out their services. But before attempting to fix the audio on the machine, I'm gonna build the BlueSCSI version 2. This one was a donation from Ronnie, a friend and a viewer. He's also into retro computers, but more on a different level, where he makes emulators for old Norwegian computers and operating systems. Hopefully I got everything I need. This is based on the Raspberry Pi Pico, and I have one here. This is with Wi-Fi. I'm not sure if that is something you can utilize on this or not. As usual, I haven't researched a lot about this, and I take it as I go. What needs to happen here is we need to solder this onto this PCB. And speaking about PCBs, if you need custom-made PCBs like this, you can actually use my sponsor, PCBWay. Not only do they produce blank PCBs that you have designed, but they can also populate them with components like this. Yeah, besides that, there's a SCSI connector. Where did I put that? And yeah, it's here. And a couple of jumpers and a power connector. So this should be an easy build. Anyway, I'm gonna power on my soldering iron, and then this should be done quite quickly. And this Raspberry Pi Pico, I'm not sure if it's programmed with the correct software, but that's some of the things I'm gonna figure out as I go. Now first to the soldering. Even though it looks quite simple to assemble this board, I'm gonna read through the instructions. There might be some hidden stuff there, and that's important to know. I have done mistakes before by not reading documentation. For example, installing this the wrong way on the wrong side. In this case, I'm pretty sure it's gonna go on the top, but it could be on the bottom. Alright, then some soldering. Yeah, then just a bunch of pins to solder here. It's gonna be quickly done. These pins are quite thick metal, so they draw a lot of heat, but I have my soldering iron on 395 Celsius. Yes, that looks good. Backside, front side. Yeah, a little bit of cleanup. Yeah, then we have the SCSI connector. Yeah, see one bent pin there. Yeah, now it's in. Yeah, and he's like, how many pins? 50. So just solder the 2 corner pins and then try to push it as hard as I can to make it flush. We don't want any gaps, do we? Yeah, this is just a bunch of soldering. I complete that and then I'll be back. So that's done then. A little bit of cleanup. Finally we have the power connector. So I just hold it down and re-solder. Yeah, it fell down a little bit. You feel it. So it came with 4 jumpers, but it didn't come with pin headers for them. I see here there's one for target, power on. That might not be for the jumper. There's something there. Yes, I realized that it didn't even explain what the BlueSCSI is. So let's take a look at the documentation and the GitHub page. Yeah, it has its own web page, bluescsci.com, and here we can read a little bit about it. It's an open source, open hardware and open design SCSI solution for vintage computer, and the SCSI, it's a hard drive interface obviously, and this Macintosh Classic has a SCSI interface. Many other computers in the early ages had SCSI, and after that home computers started to come with IDE interfaces. Then SATA. I think SATA is the current standard still. Yeah, and here it says it's based on the Raspberry Pi Pico microcontroller, and it's fast, pushing 10 megabyte per second. Comes in 3 models, has a ton of new features. It's available now to build yourself or buy. I guess you can build, you can get a kit both with or without the different surface mounted components. I'm glad I got it with. Yeah, and here it talks about some of the new features. It has a BlueSCSI toolbox, which allows you to transfer files to and from your vintage computer directly to your SD card, change CDs on the fly, ROM disks. Apple first, but not only. It's no secret that the core BlueSCSI developers are Apple fans. Yeah, so that's a little bit of information about this project. And here's the full documentation. So here it tells you about usage, emulators, different types of images it supports, how to update your firmware, transferring files, Wi-Fi, Amiga. Yes, and by reading the assembly guide, I actually see that there's some termination headers that needs to be set, and they are required. So that means if you need to have this terminate your SCSI connection, you can use that jumper. So I guess I just set it to termination on. Then there's a power header, and this one I suppose indicates if this board is powered externally or not. Yeah, here's the SD card interface, so we just need to find the SD card to check out. Let me open up the machine, but there's a problem with that. Or not a problem perhaps, but it's not easy to open this because you need a very long screwdriver and it's Torx. So I don't have such a long screwdriver. Luckily I didn't put in the screws here up in the lid the last time I had this machine open. Big bolts. Yes, I know this has been powered on yesterday, so it could potentially hold some couple of thousands volts, and that's not good if you touch it. It can be dangerous, so be careful if you work with CRT screens. Yeah, and here's my contraption with the previous BlueSCSI. Just taped it in like this. Yeah, here we can see the difference. This is much smaller. It has a micro SD card slot, and it also has a small microcontroller. This is based on the STM32. So then I can just take this micro SD card out here and use it and insert it into here. Check that it's not locked. And then I install this, try to not touch anything. It should go this way, and it's not necessary to power it because this provides power. So then we need to set the jumper, or no, not set the jumper, I think. We'll see what's gonna happen. Yeah, let's see if it works. Now it has the floppy disk inserted, so it might start booting from that, but we should still see the hard drive when it boots. But there's no light, no LEDs flashing or anything, so I think this is not powered. No, it didn't show any hard drive. The disk out, yeah. I turn it off and then I'll try to set the jumper for the power. I probably misunderstood. Yes, now we have some lights. So does it do anything? There might be more to do to get this up and running. As usual, I just start off by don't reading the manual or anything. Nope. Well, I have no idea if it did anything. I'm just gonna restart the machine again. Nope. Well, it doesn't seem to have done anything with the update, so I'm trying the USB method, where you're supposed to hold in this boot selector here and then just drop the file into the disk. Okay, let's try that. Yes, and now just find the file. So I just moved that file over there. It should update the firmware and then remove the disk from the machine. There it went away. Yeah, I think it's flashed now. It's blinking green. Let's see now then. Nope. Still no luck. So I've been trying to get this to work for a long time now. I tried different things. I know that the firmware is running because I added an ini file, the BlueSCSI ini file, and I enabled debugging in that, and it actually writes to a log file, and there I can see that it actually finds the image and initializes. But then nothing happens, and there's a bunch of commands being sent, but Macintosh doesn't see this drive. So I was thinking this should work. The documentation clearly says that the Macintosh Classic should work right out of the box. Alright, so I took out the memory card, and if I check the log file now, it says here BlueSCSI and 2025. Here it starts, and it is finding images. There it found the image I actually have on the memory card, the HD00512. It says it's contiguous. Here it says initialization complete, but there's just some busy and bus free. Okay, it's been a couple of days, and I have tried a lot of different things when it comes to configuration of the card. I tried to downgrade to an earlier firmware, and nothing seems to help, so I started a discussion on the GitHub page of this project, and I immediately got a reply, and according to the log, the reply says that seems like one of the lines on the data bus is constantly high. So I checked that now with the oscilloscope. I'll have to take out the motherboard, and that was my plan anyway, to check out the issue with the audio. Yeah, I put this on top here to avoid being shocked. I noticed a couple of times that I inadvertently put my arm here, touched this, didn't get shocked, but yeah, it's definitely dangerous. So the motherboard should just pull straight out. I need to take out the RAM and some connectors that goes to it. Yeah, and it isn't big. Looks alright. Anyway, the original issue with this machine was that it had a leaky battery, and it had leaked for a long time. Apparently it didn't damage the board, but it had leaked onto the metal, and you can see there's some damages. And there were big rust patches all over the metal, like this big area here. I cleaned that up, and it's no longer rusting. That's a couple of years ago at least. But there's no audio, and there might be some other damages that I didn't notice before. I'm gonna check around. There seems to be a little bit of like liquid around here. Maybe there's some damage from the battery after all. Yeah, you see it here. It's definitely wet looking. I think there is something there, but there are other places here which look affected. This chip, for example, quite gray, and obviously the capacitors over here, they look to have been leaking. Yeah, and over here too, and those are my suspects for the missing audio. So what I'm gonna do, I'm gonna replace the caps. They're all 47 microfarads, 16 volts, except this small one here. I'm not sure what it is. I'm not gonna order and wait for new caps for this board. I have this kit. It has 47 microfarads, 35 volts. I guess they're gonna be okay. Yeah, just need to make a note of the polarity, see if it's okay. Yeah, it seems to be negative all the way to the left on that one too, except this one, it's up. Okay, I'm just gonna start with these. I'm not gonna show you the replacement of all these caps, just add a little flux first. Yeah, the pads look very grayish and affected. Hopefully the pads are not damaged. There's always a discussion what's the best way to remove these surface mounted caps. I have tried different ways. Some prefer hot air and yeah, risk blowing up the capacitor. I prefer to use 2 soldering irons. You can use 1 also if you want, but using 2, you just melt the solder on both sides. Yeah, and this he refuses to come loose easily. Okay, then I'm gonna add some fresh solder. That helps too. Well, it won't take. Simply don't wanna take. Oh, and it smells fishy. That's leaked electrolyte. It always smells fishy. Problem with the electrolyte is that it changes the solder, the chemistry of the solder, so it doesn't want to melt. But I'm very scared about ripping the pads. Yeah, it's loose. A little bit patience helps. Yes, so it wasn't that hard after all. Let's have this one close up. I'm not cutting now, so you see what time it takes to melt it. Yeah. Alright, I remove the rest and then I'll be back. Yeah, I said acid, but I think in fact the capacitors, they're not acid, they're more like base. I actually prefer to use a little bit of vinegar when cleaning up after leaked capacitors. I just have some vinegar on this Q-tip. Just leave it a few minutes. Important thing is to clean it away afterwards. And around this chip. Yeah, there's actually several chips that looks to have a little bit of grayish pins. Yeah, I think that's enough with the vinegar, and I'll leave it there for some minutes and then I'll be back. Well, I'm already back. I forgot to check the back side, and it looks fairly good, but I can see around here there has been some corrosion, especially this one, R88. It looks all green and crusty on that side. I'm not sure if you can see it. Yeah, so just using a little bit vinegar here too, and let it soak for a little bit. Okay, it's been a while. I'm cleaning this up now with lots of API. You can of course rinse it off in water, but I don't like to do that because water gets in everywhere. So now it's cleaned up, and I'm just gonna remove the old solder from the pads. Just use a little bit of, yeah, this is more like liquid flux. Yeah, that looks good. Shiny and nice pads. So I'm trying to figure out what this little capacitor is valued at. I cannot see it. It's 50 volts for sure, but the capacitance I cannot see. I need to find the schematics. Yeah, with some googling I found out that C3 here is 1 microfarad, 50 volts, and I have one here. Start with that one. I use a little bit of flux. No, it was not that one, it was that one. It can be a little bit fiddly to solder on these caps, but usually it's quite easy after all if you have a little bit of practice. So I just tin the pads first a little bit. Yeah, that sits nicely there. I just tin the other ones at the same time. Yeah, now comes the fun part. Placing these correctly and soldering. It's kind of small, but manageable. Just place it, align it with the pins, I mean the pads. Melt the solder on one side. Yeah, that's okay. And it's not straight, so I need to resolder and then turn it a little bit. Now it's aligned. Yeah, that's solid. Yeah, and all the rest were the 47 microfarad. I guess some of these capacitors are responsible for some filtering of the sound, because here's it says sound here. Yes. Now I wonder about these buttons here. What are those for? I mean, they're on the motherboard. They're not available outside the machine. If you know, tell me in the comments. Anyway, the caps are on, looking good. And no, I just thought I'd just try to resolder around this chip. And yeah, I just used a little bit flux and then just dragged my iron around it without any solder, just to see if it maybe improves the soldering under it. Yeah, that seems to make it look better and shinier. Yeah, while I'm at it, I'm going to do the same with a couple of other chips that looks a little bit suspicious on the pads. I mean, this is not for trying to fix anything, it's more like future proofing, since I can see some signs of corrosion. Okay, I think I finished so far. Just clean up the mess here. I did a few more of the chips off cam, you know. Okay, back with the contacts. Okay, let's test. I think we're supposed to hear a ding when this machine powers on. Yeah! Cool. We heard a ding. I need to hear it once more. A nice little ding. Sound is restored. Then the next issue. Does this now work? First I'll try without powering it. You can obviously power it with USB if you want. I measured that the input voltage for the 5 volts was just 4.1. Might be a little bit low, we'll see. According to the discussion I had on the BlueSCSI page on GitHub, you should not have to set any settings in the BlueSCSI ini file. I removed the configuration I have on this memory card, and then let's see if that does anything. And then we get the fresh log file. Still nothing. So what does the log tell us now? Yeah, here it says it still tries to send out a command, write 6, and according to the discussion I had on The GitHub page tries to write here out, and it comes out with the wrong data, which has added 2 to all the bytes, and that seems plausible with the case that we saw that the data line number 2 was high always. So it's supposed to be 08, 00, 00, 00, 00, 01, 00, and yeah. So we still have that issue. So there's no easy way to power this on without having it in the machine, since the cables are so short, and that makes it a little bit difficult to debug. Yeah, this chip here, the NCR53C80, is in fact the SCSI drive controller chip. And according to the schematics, here's the 53C80, the SCSI controller chip. This is the signals that goes out to the SCSI contact. And here's DB0, 1, 2, 3, 4, 5, 6, 7. So DB1 is pin 38 that goes to the SCSI connector. Pin 38 goes to pin 4 according to this. And the chip pinout looks like this. Pin 1 is over here on the top in the middle. And the number goes around like this, 38. DB1 is the second last one on that side. So that's like this, and pin 1 is there, so pin 38 is there and 27 is there. But I'm gonna concentrate on pin 38 first. So if my assumption is correct, then pin 38 should be there, yeah. My assumption was not correct. This is, over here is pin 2 and that's pin 4. And I was measuring around here before. And with the connector in, then it gets a little bit more confusing. Things might turn around. But I figure it's this pin there, pin 38. No, it wasn't. It was in fact turned over to the other side now. Yes. Okay, so now I have definitely found pin 4, which is the DB1 signal. I'm gonna check that on the oscilloscope. And the pin right before DB1 is DB0, so I can compare it to DB0. So if we see this pin number 4 is high or low all the time when it actually should show some activity, then we know there's an issue with the computer. Yeah, it actually has a signal. It switches between high and low. So then the theory is not correct after all. Yeah, you can see activity there. That's D0, that's D1. Normal activity there, D2, D3, D4, D5, D6, and D7. So the theory about one line being stuck, this is D1 or DB1, it's not correct after all. So you might think that the signal seems a little bit low. It's just, yeah, it's a little bit below 3 volts, but the SCSI standard, as I understand it, says that anything below 2 volts is high and anything above 2 volts is low. So then this signal is perfectly fine. So what's happening now is that the BlueSCSI is trying to send data to the computer and get a reply, and then it cannot interpret the signal it gets back, so that's why it doesn't boot. But this seems perfectly fine. So for me this looks like the computer is behaving actually as it's supposed to be, and if the BlueSCSI is logging the wrong values, then the fault might just as well be on the BlueSCSI itself. It can be it that adds to the values. I have this board layout here where you can follow the traces, and if you check the pins for the data bus, they're here, and yeah, they go directly to these two chips over here. So those are probably just some logic gates. Yeah, and I couldn't find anything wrong here. I measured all the resistors here and all the pathways in between. The signal goes through these two chips, and I think this takes it down to 3.3 volts, and then it goes through these resistors. So these are the 8 data lines, and they make their way to this side of the Pico. So I might want to try and check the signals on the Pico. Yes, and now I see something strange. DB1 looks normal. DB2 does not. It's totally flat. It has a little hump, but it's too low. DB0 looks normal, has activity. DB1, donk. Not much going on there. There's a little spike there, but it's way below 2 volts, so it doesn't change anything. So as I said, low means high on the SCSI, so that actually is a low, and that will add 2 to the signal, to the bytes. And if we check the other data lines, they too look fine. Alright, that was a lot of digging, but I actually found the fault, and where is it actually on the board? Yeah, it could be the Pico itself that's damaged or something, but I just need to measure out the pathway between here and here and here on that line. It could be a bad soldering, but it looks alright. So I see nothing wrong there. So it's this resistor here. I try to zoom in. It could be this chip that's faulty. This is just a bus transceiver, a 3.3 volt bus transceiver. Anyway, it just transports the signal from one side to the other and boosts it to the correct voltage. That's the work of that. So we should see a path from here to that resistor and then over to here. Let's see now if we have connection to the resistor. Yes, we do. Is it shorted to something else besides? No, it is not. Is it shorted to ground? No, it's not. It could be the Pico that's holding that pin down, of course. So to check that, I actually need to remove the Pico. Alright, so I took out the Raspberry Pico and replaced it with another one. This is an older model. It doesn't have the Wi-Fi built in, but it should be the same. Hopefully I already programmed it with the firmware and it didn't complain or anything. So let's see if this one works then. Hopefully there's no compatibility issues with this Pico. It's a happy face. Yes, it says System 7 needs more memory to continue. So it actually works. Okay, nice. So it was the Pico then that was faulty. Better insert the memory module then. Now this is powered by the machine, no external power. Let's see what happens when I turn the machine on and it boots. There's one green light. Yeah, now it both blinks away happily. And we have a welcome to Macintosh. Now it's a little bit better, no glare from the roof light. Okay, it booted and it apparently works just fine without any special configuration or settings. So all that work for a faulty Raspberry Pi. It could be that it wasn't faulty when I got it, but I managed to damage it either by some static electricity or something else while soldering. You never know. So about the sound, do we have anything that makes some sound here? Not this one. Yeah, I don't know how to play it, which keys to use or anything. Didn't actually have any sound, but in the settings we have some sound settings in the control panel. There we have it. Yeah. Yeah. That's a little bit too loud. Anyway, I'm happy I repaired this machine now. It seems to be working very nicely. Just one final test. If I survive, I'm gonna try another hard disk image that I downloaded. Now, I downloaded something called MacPack. It supposedly has 1000 games. It has a couple of VHD files, but I'm not entirely sure if they are supported as is. But let me just try. Maybe you need to do something with them before the BlueSCSI can read them. Yes, it actually booted, and now into the English version of Mac OS. So these are in fact VHD files. It was in English now. I remember I upgraded the same image last time I filled with this, and I upgraded to the Norwegian version. But there was another image over 1 gigabyte. Let's see if I can get it to boot that. Yes, happy Mac. Now this is a 1.4 gigabyte big virtual hard drive, and it supposedly has 1000 games on it. I have no idea what's on it and if it's compatible with this old Mac Classic. Oh, I think this is a newer version of the Mac OS. Maybe this machine is a little bit weak for that. Yeah, it says sorry, a system error occurred. Probably too little RAM then. I started with the extensions off. You know, the old Mac OSs is something I have never used before back in the day. Yeah, now it actually worked. There is a system picker here, and supposedly that should make it possible to change to an older operating system. Well, select the system folder to be active. However, it takes several minutes for it to start booting, and that's not fun. Sitting around here watching that happy Mac face for 5 minutes waiting. Yes, I got the system picker to work, and here you can select which operating system you want to run, and according to the README file it's recommended to use version 6 because of compatibility with games. And then press restart. It should boot into system 6. That doesn't require that much RAM. Yeah, now it actually booted straight away. No waiting here. Big screen program. Use normal screen, I think. Nice photo background. Let's just go straight into the games. Let's try 1985. See what's there. Airborne. That sounds fun. Yeah. Okay, I'm not gonna play, but it's still fun just to to try something. I have no idea what to do. Oh, you're the little guy there. But how do you fire? And then it crashed. Hanging. No can do. Command Q supposedly should exit the running program, but it doesn't. Seems like if you restart the machine from the operating system, then it boots quite quickly, but if you turn it off and on, then it takes forever to start booting. I see the BlueSCSI and the Pico is blinking, so there's some activity. There's an applications folder too. Coding, creative, graphics, music fun demo. Yeah, it's music fundamentals. Open or create a score file. Okay. Okay, let's exit that. But we have a lot here. Office, Microsoft Word. I wonder if that's gonna work here. No, it needs at least 5 megabytes. Stunt copter. That sounds fun, doesn't it? Yeah, you can use the mouse here. He died. I hit the horse. Well, that was the Macintosh Classic. I did what I planned to do, and that was to fix the audio problem, and also got to change all the caps and clean up the board a little bit. Also, I wanted to test out the new BlueSCSI version 2, and it worked eventually. Too bad I couldn't test the Wi-Fi feature, because supposedly you can get this machine onto the internet, and you can also use the Wi-Fi to transfer files from another computer. But I was thinking maybe that's enough for a whole video in itself, so I might do that on a later occasion. So I hope you enjoyed this video, and I hope to see you back next time. And thanks for all the subscriptions and likes, and a special thanks to my patrons. See you, bye bye.